Hello, this is Adam Taylor. I'm a wood product specialist in Knoxville. Just want to spend some time introducing you to wood identification, specifically for the 4-H contest. Wood ID is intimidating to some people, but with a few simple rules and a little bit of practice, you can do a great job of wood ID with a hand lens. First thing to know is how to look at wood using a hand lens. You can use a simple 10x, 10 times magnification hand lens to see all the features that you need to see to do a good job of identifying the species for the 4-H contest. There is a proper way to use a hand lens and other ways which aren't as effective. The best way to use a hand lens is to hold the hand lens about an inch from your eye, steadying it against your face using the back of your hand. You then move the wood into focus by bringing it closer to your face. This works a lot better than holding the hand lens against the wood block and moving both of those towards your eye. It's also very important to know which direction, which face of the wood block you're looking at. If you imagine a tree, those cells in the tree are mostly oriented up and down, that is, from the roots up to the leaves, or in parallel direction to the stem of the tree. So if you were to cut the tree off and look down at the stump, you'd be looking at the end grain, or what we refer to as the cross section. In this face, you're going to see the cut off ends of a lot of cells, and for wood identification using a hand lens, this cross section is going to be the most useful face to look at. On the cross section, you can see pore patterns in hardwoods, resin canals in softwoods, growth ring patterns and the presence of growth rings, and also parenchyma patterns. And all of these features I'm going to talk about in a few minutes. The other faces of a wood block can be useful also, but they're not as useful as the cross section. If you were to peel the bark away from the side of a tree and look into the tree, you'd be looking at the tangential face as shown in this picture. In this face you can see the ray height, so for species with large rays this can be helpful in making an identification. Also, if you were to split this stump from the pith or the center of the tree out to the bark, you'd be looking at the radial face. The radial face may also be useful for looking at rays, which are a feature that I'll talk about in a few minutes, and the ray fleck in particular on the ray face. So for certain species with large or distinctive rays, the radial face can also be useful. But the most important face to look at is the cross section, so we'll focus most of our attention on that face. For the 4-H contests, wood blocks will be prepared for you with good clean surfaces that are visible using a hand lens. However, when you're doing your practice, it is important to have a good, clean, and clear surface to look at, and this may involve the use of sharp cutting tools. The most important thing here is to be careful, because it's very easy when cutting wood, which is a hard thing to cut, with sharp blades to cut yourself. I've done it, and I know. A couple of tips to keep in mind is to create a clean surface using a saw and then finish up a very small section using something like a razor blade or a sharp pocket knife. It's important to note you only need a very small surface to look at. When you're using a hand lens on a small section, you really don't need to smooth the entire face of the block. Something the size of the eraser on a pencil is going to be more than enough to see the features that you need to see. Another tip when trying to cut wood is that wet wood generally is going to cut more easily than dry wood. So getting the wood wet, even soaking it in warm water for a time, can make it a lot easier to cut a section and get a good clean cut. Again, the most important thing though is to be careful. Keep your fingers out of the way of any blade. So the features to look for, the items that you can see when looking at a piece of wood, include the following on this list. Growth rings. Here in the temperate forest, there are annual variations in the growth of a tree. In the spring, trees grow a new layer of wood to help conduct water from the roots up to the leaves, and this is called the early wood, or sometimes the spring wood. Later in the summer, many trees will grow a distinctly different layer of wood that's more for mechanical support than water conduction. And this combination of differences between the early wood and the late wood, or the spring wood and the summer wood, leads to visible changes in the growth ring. And you can count these growth rings to get the age of the tree, but also the distinctiveness of these growth rings can help you to identify certain species. The color of wood can be very helpful in certain species. For example, black walnut has a distinctive black or chocolate brown color. However, color is highly variable between trees and even within the same tree, so it's good not to rely on this without some other feature that helps you to identify a particular species. Another feature that's easy to observe is the hardness or density. Simply by weighing the block of wood in your hand or trying to dig into it with your fingernail, you can get some idea of how dense the wood is and how hard it is. Again, this is a very variable feature and shouldn't be relied on solely to determine the identity of a particular species. However, it can help. For example, oak and hickory are hard and dense woods, whereas cottonwood and poplar are softer. The odor of some species can also be distinctive. For example, red cedar has a distinctive cedar smell. However, old pieces of wood which you may encounter in a wood ID contest, for example, may have lost much of this smell. So again, this particular feature shouldn't be relied upon. In addition, many species don't have a very distinctive odor when they're dry. But in some cases, this can help. The growth rings, the color, the hardness, and the odor are all things that you wouldn't need a hand lens for. Some other features that are going to be, in fact, more helpful but may require a hand lens include pore patterns. And this is arrangements of the cells. You'll see these in cross-section, and I'll show you some pictures of the three types. But in summary, hardwoods have three ways that their large cells can be arranged, either in a ring pattern parallel to the growth ring, or a diffuse pattern where the pores are the same size across the growth ring, or somewhere in between called semi-ring or semi-diffuse porous. Rays are groups of cells that are oriented across the major grain of the wood. That is to say, these cells go from the pith or the center of the tree out towards the bark, whereas most of the cells in a tree are oriented up and down in the tree from the roots up to the leaves. These groups of cells can be large, resulting in a large ray, or small, resulting in a small ray. All trees, and therefore all wood, have rays, but in some cases they'll be easily seen even with the naked eye, such as in the oaks and beech, whereas in other species the rays are relatively small and would be very difficult to see with even with a hand lens, for example in cottonwood. Parenchyma are specialized cells that are active when the tree is living. They help to maintain the function of the wood. Parenchyma cells are visible usually with a hand lens, but even sometimes, for example in black locust, they're visible to the naked eye. It's not so important to know what the parenchyma are doing in wood. It's just nice to know that in some species they offer very distinctive visual clues as to the identity of that particular species. For example, in hickory, there are distinctive parallel bands of parenchyma that once you've seen them will help you to identify hickory with no trouble. Growth rings, I already mentioned, are a feature that can be used to identify wood macroscopically or without a hand lens, but they can also be looked at with a hand lens to get more idea, particularly about the pore pattern. So growth rings and pore patterns kind of go together. Resin canals, finally, are a feature that's visible only in softwoods. There are two softwoods in the 4-H wood identification contest. Red cedar is a softwood. It does not have resin canals, whereas southern yellow pine does have distinctive resin canals, which can be seen even with the naked eye, but clearly with a hand lens. So we'll go through and see some pictures of these various features. So here's some pictures of growth rings. On the lower left is southern yellow pine. The lighter colored wood is the early wood, or the spring wood, which was grown in the spring and is less dense. The darker bands of wood are the late wood, or summer wood, which were grown later in the year and are more dense. So you can clearly distinguish the annual growth rings of southern yellow pine based on the differences between the early wood and the late wood. In the upper middle section, we have a ring porous wood, and its growth rings are distinct because of the difference between the size of the cells, or the pores, in the early wood, where there's a band of relatively large pores, versus the late wood, where the cells are small enough that the large openings are not really detectable in this picture. Finally, in the lower right, we have a picture of black walnut, which has maybe a semi-diffuse porous nature, where the growth rings are less distinct because there's less of a difference between the early wood and the late wood. Here's a picture of pore patterns, and again, pore patterns are only seen in hardwoods because only hardwoods have the special cell type called a pore, or a vessel. On the left, you see distinctly ring porous hardwood, where there's a ring in the early wood of relatively large pores. Later in the late wood, later in the growing season, the late wood has relatively small pores. So there's a distinct difference between the early wood and the late wood in a ring porous hardwood. In the middle, black walnut, we saw a picture of it in the previous slide, where the pores in the early wood are slightly bigger, and then they get slightly smaller and end up quite small in the late wood. But it's not an abrupt distinction between the early wood and late wood as there is in the white ash that was shown at the left. The third type of pore pattern in hardwoods is the truly diffuse porous, like we see in yellow birch. Here, the large pores are the same size all the way across the growth ring, and usually in diffuse porous species, the pores themselves are much smaller than you would see in the early wood of a ring porous species. Ring porous species are pretty easy to tell that they're ring porous, but it can sometimes be difficult to distinguish between the semi-ring porous and the truly diffuse porous hardwoods. Just a reminder that pores, the specialized feature of a certain cell type, is only found in hardwoods. If you look in the lower left-hand picture, you see an electron micrograph, or a very close-up view of a hardwood, and there you can see that the pores, even though they're small in the picture above it, so small that they can't really be seen, if you look very closely, you'll see that there are relatively large cells surrounded by relatively small cells. Those large cells are called the pores, and that's why hardwoods are called porous woods. Softwoods, of course, have cells with openings, which makes them porous in one sense, but technically speaking, they don't have the specialized cell type that results in a pore. If you look in the lower right-hand picture, an electron micrograph of a softwood shows that all the cells look relatively uniform. There are no cells that are large compared to its neighbors. Therefore, a softwood is technically non-porous. I mentioned that color can sometimes be a distinctive feature. Walnut is famous for its chocolate brown color, which makes it very attractive for use in cabinets and other decorative items. Cedar has a kind of rusty red color, but often has streaks of white within that red color. That's called included sapwood, and is kind of distinctive to cedar in this group of species. Yellow poplar, despite the name yellow, is often green in its heartwood. However, keep in mind with color that it can be quite variable. The colors that we associate with particular species are usually found in the heartwood only, and so if you have a piece of sapwood, you won't see the color that you expect to see with that species. So color is a good feature to look at to back up other observations that you've made. Hardness, I mentioned before, is a function of the wood density. Density is something that you can feel, or if you look at this diagram, you can measure the density by taking a stick and seeing how far it submerges into the water. However, hardness or density is a very variable feature and shouldn't be relied on by itself to make an identification. Here's a cedar chest with the streaks of white often within the red color. Cedar also can have a distinctive odor, as do all species if you find them green, but in dry wood the odor mostly goes away. Even in cedar it'll go away after a while. It might help to cut into a piece of cedar, something that you suspect is cedar, to release some of the trapped odor on the inside. But again, do not depend on odor for an identification. Use it as a backup for other observations. Rays are the groups of cells that extend from the pith or the center of the tree out to the bark, and they can show up as dark lines against a lighter background when seen in tangential section and radial section. Tangential section, again, is if you were to peel off the bark from a tree and look in, you would be looking at the tangential face. And in species with large rays such as beech, sycamore, and maple, you can see the dark lines that are the rays. In radial section, when you split a piece of wood from the pith or the center of the tree out to the bark, you're cutting basically across those rays, and those rays show up as a smear or a ray fleck. This is mostly visible in species that have relatively large rays, for example, beech, sycamore, and maple, as shown in these pictures. Oak is another species with very large rays. Parenchyma patterns. Parenchyma are the specialized cells that aid in the functioning of the tree and of the wood as the tree is living. The parenchyma can give you distinctive patterns that show up as light color against the dark background of the surrounding cells, and this is seen in cross-section, or if you were to cut a tree down and look into the stump, that's the section that the parenchyma would be most visible. So, for example, on the far left, we see the parenchyma surrounding the latewood pores and making the latewood pores show up as a white dot. In black locust, you would see the same thing, but more of the parenchyma so that they tend to surround and connect the pores. Black locust can be very readily identified by the presence of these parenchyma surrounding the pores. Yellow poplar growth rings. Yellow poplar is a diffuse porous hardwood, but the growth rings stand out because there are marginal parenchyma, which means that there's a line of parenchyma in between the annual growth rings. And if you see in this picture, the second from the right, there is that white line that's going across the picture. Those are a line of marginal parenchyma which indicate the growth ring boundary. In hickory, I mentioned before, there are distinctive bands of parenchyma that are parallel to the growth ring. Those fine white lines, again seen in cross-section, are the banded parenchyma, which are distinctive for hickory in this group. So parenchyma are something really useful in terms of wood identification, and if you have access to a piece of hickory, I would urge you to look at the cross-section and find those white bands of parenchyma. Resin canals, I mentioned, are a feature of softwoods only. Hardwoods do not have resin canals. And cedar, which is a softwood, is a non-resinous species and contains no resin canals. However, in southern yellow pine, the resin canals are visible as white dots, particularly in the darker colored late wood of the annual growth ring. So the picture on the top shows the presence of some of those white dots in the late wood of southern yellow pine. Here's the official wood list for the 4-H contest. I've talked about some of the features that are important to look at when you're trying to identify wood And I began with an explanation of how to properly use a hand lens and how to properly look at the faces of wood. So remembering that if we hold a hand lens in front of our eye and bring a piece of wood in to focus and have a nice clean cross-section to look at, and we look for the various features that I mentioned, we'll have no trouble distinguishing most of these species. I'll admit that some of the species are kind of tough to distinguish, but many of them are very easy once you know the particular features that are distinctive to that species. So I'm going to go through this official wood list and explain some of the key features that will help you to identify these species. Southern yellow pine, as I mentioned, is a softwood, so it won't have pores. A distinctive feature for southern yellow pine are the presence of the white dots or resin canals that show up irregularly spaced, particularly in the late wood. They show up as a white dot against the dark background. Red cedar is also a softwood. It doesn't have pores. It has a distinctive odor and color, particularly in fresh wood samples, and no resin canals. The distinctive color is red, often with streaks of white, so-called included sapwood. Red cedar is also a fairly soft or low-density wood compared to southern yellow pine. Moving on to the hardwoods, oaks have wide rays which show up as light lines against a relatively dark background in the cross-section. And you can see these wide rays in this picture going across the growth rings. Oak is also distinctly ring porous, and you can see that in cross-section here where the large bands of large vessels are very distinct from the late wood, which has very small vessels. So oak has wide rays and is distinctly ring porous. Oak is also hard, but if you can find the wide rays and the ring porous, you should have no problem identifying oak. Ash is similar to oak in that it's distinctly ring porous. You should be able to see the bands of large earlywood pores in this picture. But notice that the rays, or the white lines that are going perpendicular to the growth rings, are very small for ash. So ash is hard like oak and ring porous like oak, but unlike oak, it has narrow rays. Hickory is ring porous and hard and has narrow rays. But hickory, if you look in cross-section, has distinctive wavy to straight bands of parenchyma that show up as white lines that are parallel to the growth ring. Again, find a piece of hickory, look at the cross-section, and find those white bands of banded parenchyma, and you'll have no trouble distinguishing hickory from ash. Black locust is a pretty easy species to determine because of its distinctive dark color, the fact that it has lots of lighter colored parenchyma surrounding all of the vessels. There are also tyloses in black locust, which is a feature that I haven't talked about before, but basically they're a filling that blocks up the large pores. So if you look in this picture, you'll see that the pores, which are visible because of the surrounding parenchyma, you can't see into them because they're filled with a tylosis. So with black locust, it's a ring porous, hard, dark-colored hardwood with very distinctive parenchyma that surround all the vessels. Elm is also a very easy species to identify once you know what to look for. Elm is relatively hard, it's ring porous, but its parenchyma and late wood pore patterns give it away. If you look in this picture, you'll see in the late wood there are wavy bands of late wood pores that are surrounded by parenchyma. So you get this kind of wavy striped appearance that is very distinctive to all of the elm species. So once you've seen that, you can distinguish elm even without a hand lens. Cherry is a semi-ring porous species. that often will be confused for being truly diffuse porous. But if you look carefully in this picture, you'll see that in the early wood the pores are slightly larger than later on towards the late wood. Cherry has medium width rays, which show up clearly in this picture as white lines going across the growth ring against the dark background of the surrounding cells. Cherry also has a distinctive color, cherry red color, which is prized in its cabinetry and furniture applications. If you look at the radial face of cherry, because of the fairly large rays, you'll see a distinctive ray fleck. But the things to remember with cherry are the distinctive color, the medium width rays, and the semi-ring porous pore arrangement. Walnut has a distinctive color, a chocolate brown color. It's also semi-ring porous and sort of medium density, not the hardest nor the softest wood in this group. Sycamore has very wide rays, which show up clearly here in this picture as white lines against the darker background in cross-section. Unlike oak and ash, though, or oak, which has wide rays, it's diffuse porous. The larger cells are the same diameter going across the growth ring. Sycamore is sort of medium density, and the growth rings are distinct due to the presence of parenchyma at the margins. But sycamore is diffuse porous with large rays. Beech is also diffuse porous with wide rays. However, beech is a little harder, and also the amount of rays and their size are quite different between beech and sycamore. What I would do to learn the difference between beech and sycamore is get a block of each and put them side by side. If you look at the tangential section and look for the rays, you will clearly see that there's a difference between beech and sycamore, that once you've seen it won't be confusing. Maple is diffuse porous with medium width rays, kind of like cherry, except that maple doesn't have the distinct color that cherry does. And cherry is semi-ring porous as opposed to maple, which is truly diffuse porous. Moving on now into some of the more difficult species to distinguish. Birch has narrow rays and is diffuse porous, but is relatively high density. Cottonwood is semi-diffuse porous, but because of the small size of the pores, this can be very difficult to see to help you distinguish it from birch. But if you look in this picture, I think you can tell that early in the growth ring, the pores are a little larger than they are towards the end of the growth ring. Cottonwood is also low density, or relatively soft. Yellow poplar is a diffuse porous, medium density species. The growth rings are distinctly visible because of bands of late wood parenchyma, and yellow poplar can often have a sort of greenish color in the heartwood, which can be distinctive. Gum is medium density, diffuse porous with narrow rays. There's really nothing distinctive about gum, so the way you can distinguish it from other species is by the lack of other features rather than by the presence of some distinct feature. So when you're getting into gum versus cottonwood, it can be pretty tough, and this is where practice comes into play.